Good afternoon. My name is Alan Hart. I'm the Design Standards Manager. I work here in Central Office, and I work with the Design Standards e-booklet, updating and revising design standard indexes. Today we're going to be doing the design update training for the Design Standards e-booklet. The Design Standards e-booklet page, this is what it looks like, and I'm going to give you a link to that. Oh, we'll go back. Down here is the link to the page. You can use that to get to the Design Standards ebook page. And then once you get there, you can click on the DSEB, which is the Design Standards e-booklet link. That will take you to the 2015 Design Standards e-booklet page. And I've got a small cutout of the Design Standards e-booklet page. This is what you're going to see whenever you pull it up. I'm going to kind of highlight a couple of things as we go through. On the left side here, we've got our index numbers. You can actually download the complete e-booklet by clicking on the link here, or you can go down and download different indexes as you need them. They're all in PDF format. Most of us are probably used to this now. Going over, you've got your index title. That's just the title of the index. Instructions for design standards. I'm going to come back to that in a little bit. We'll talk a little bit about that. The data table cell library column. Anytime there's a cell library that corresponds with an index, you'll see that here in this column. One of the things I did want to highlight is the roadway contact, drainage contact. These are excuse me, these are links that you can click on, and it will take you to who is actually working on those design standards. If you need to contact someone with a question, essentially click on that. It'll get you to the contact information for the person that is in charge of those standard indexes. Finally, the borderless DGNs. As you can see on the picture that I have, we don't have any borderless DGNs. We're working to get borderless DGNs that correspond with each index that will be downloadable. You also have some that are already on the site that are downloadable. Again, if there's one that you need or one that you require, just click on the contact that corresponds to the index. Give us a call. We'll get those to you. The one thing I did want to point out is the terms of use. And here's the terms of use. Essentially here, the reason you would download one of the indexes is if you wanted to modify it for your use on your project, but it has 3 methods that you need to take a look at here. I'd just go ahead, if you would, go ahead and take a look at the terms of use. Once you pull one out and you use one of these methods, then the engineer of record is going to have to take ownership of it and use it for whatever he needs to for project-specific design. Next thing is, if you go back to the 215 ebook, you'll see the DSR. DSR is Design Standards Revisions. Design Standards Revisions, essentially, those are revisions that are made between publishings of the index. They're usually something that are fairly significant that we need to get taken care of and implemented immediately for all lettings and lettings going forward from that time frame of implementation. Here you can take a look at the Design Standard Revision page. I just want to make sure that you understand this is the 2014 Design Standard Revisions. So these happen between the 2014 publishing and the 2015 publishing. These are now currently in the 2015 index that we have put out in July. Based on what you're seeing here, you're going to see a couple of things. You'll see the index that was revised. You'll see the sheet numbers that were revised. If you take a look at I guess we'll just take a look at Index 403. Index 403, Sheet 1 of 3 was revised, and then that was guardrail transitions for existing bridges, traffic railing retrofits. If you look back up at 400, there was an IDS that was revised. The rest of them are in A because the IDSs were not revised with the bulletin. If you had a revision to an IDS or data cell or DGN, then they would be in here at that point. And then going ahead and looking over, we've got a roadway design bulletin. Anytime you have anytime you have a DSR, you're going to have a roadway design bulletin that accompanies that DSR. And you can go to the link and pull up the roadway design bulletins. And this is just the front page of the roadway design bulletin. What'll be in these is there'll be a requirement section, a commentary section, an implementation section, and a contact for the roadway design bulletin. So this is just a brief snippet of what just the front page looks like on one of these, and then, like I said, every time we issue a DSR, we'll have a roadway design bulletin that accompanies that. Now I'll get back to the instructions for design standards. If you went to the DSEB and went back to the design standard e-booklet, you're going to come up with your design standard index, and that's on the left-hand side there. On the right-hand side, on the column that we talked about before, you'll see the IDS, IDS 400, IDS 402. These are instructions for design standards. We're going to take a look quickly at just an IDS. This is the IDS. This is just the front page for the IDS 402. Each IDS will have design criteria section. It'll have a design assumptions and limitations section, a plan content requirement sections, and payment information. The IDSs are written for the designer. They go along with the index, kind of giving you some background information as to how that index was developed, how you use that index. It talks about the design, again, the design limitations, how it's implemented into the plans, that kind of thing. So this helps the designer to understand how to use the index a little bit more, and we'll point them to the criteria. Revision history. We have revision history sheets in our design standard index. Last year we had over 250 revisions to the design standards for the 2015 e-booklet. All the revisions are listed on the revisions history sheets along with a description of the changes. If you come down and you go back to the sheet again, this is just whenever you click on the e-booklet link, it's going to bring you up, and this is going to be, I'm going to show you where the revisions are. This is going to be the revisions history sheet. You click on that. This year we've got about, in the 2015, there's 3 sheets for the revision history, and each one of them are going to look very similar to this. I'm going to highlight one a little bit larger. So if you look at just 216, 216 was revised. We revised sheet 1 of 3, sheet 2 of 3, and sheet 3 of 3. And beside each sheet that was revised, you're going to see a little bit of a small description of what was revised on that sheet. Today we're not going to go over every revision. Obviously we're just going to go over a couple of the larger revisions that happened last year. But like I said, it's a good idea, especially consultants and our guys, to take a look at this revision history sheet, take a look at what's changed, how it could implement your project if there are changes to a sheet that you may be using for any project that you're going to be working on. Okay, these are the indexes that we're going to go over a little bit today. First, I'm going to hit on something real quick. I'm going to talk a little bit about Index 199. The Index 400 series, Gavin McDaniel's going to come in and talk on that. So we're going to move that down below the 517 and 518 index, and I'll discuss the 501, 517, 518 index. And then after Gavin's finished with the 400 series, Chester Henson's going to talk about the remainder of the indexes that had revisions. Index 199, just real quickly, it was deleted. The information that was in Index 199 for geotextiles, geosynthetics, that has been moved to a specification in the standard specification 985. That standard specification is currently being reviewed and completed, and will be in the 2015 design specifications ebook. So that will be that index itself has been removed. We'll move forward. These are the remainder of the indexes that we'll be discussing today. And once again, Chester's going to be discussing these. Finally, the change. I'll go ahead and discuss the change QPL to APL. The QPL, we're no longer going to have the QPL. It's going to be merged into one list, and it's going to simply be the APL. QPL is the qualified products list, and the APL is the approved products list. So moving forward, we will have the approved products list only. So that change was made and also implemented into the design standards. So there's not going to be any more references to a QPL in the design standard e-booklet. Okay, go ahead. I'm going to talk a little bit about Index 501. This is geosynthetic reinforced soils. That index has been changed. sheets 3 through 11 have been removed. All the geosynthetic products have been moved from the standard index to the APL. So any products that were listed on that 501 index now, they're going to be getting certification on the APL. Part of the reason we did this is if there's a new product that comes in and it comes in between the postings in a year, they would have to essentially wait a year to be placed on this design index. Now this will give anybody the opportunity to go ahead and get their products certified and get on the APL and go ahead and be using those during the year anytime. We have left the 2 sheets in there. These are essentially plan content sheets, and they do have a little bit of design information on them. Moving forward, the 501 index may not be there next year. We're still working through that and determining if we're going to remove that, and it will be placed in criteria, possibly in the PPM. But that'll be moving forward. Right now, we're still leaving these 2 sheets in Index 501. Index 517 and Index 518, raised rumble strips and shoulder rumble strips. Index 518 was broken up into 2 separate indexes. Shoulder rumble strips will remain in Index 518. Raised rumble strips were removed from the Index 518, and a new index was created, Index 517, to accommodate the raised rumble strips. These changes were implemented to accommodate an upcoming ground end rumble striping index, which will be Index 519 in the future. We are currently developing a developmental design standard index that will accommodate the ground end rumble striping index that we're working on. So that's going to come out as a developmental design standard, just so we can get working on that and get some input and information as to how that index is working. With that, I'm going to turn it over, I guess, to Gavin. Chester, why don't you go ahead and talk about Chester's going to discuss the Index 600.
We're going to go, this, again, Chester Henson. I'm going to go over a couple of the MOT changes. We've made some changes to Sheet 4 of Index 600. One I would like to bring your attention to is the temporary rumble stripes. We've added a general note in there that temporary raised rumble stripes shall be required for all 2-lane, 2-way flagging operations with work zone speeds greater than 45 miles an hour and a duration greater than 1 hour. If you remember, we used to use temporary rumble stripes as only trams. We have now changed that policy to where they will be required for all 2-lane, 2-way operations that meet these requirements. Another thing we've changed is the removal of Type C steady burn warning lights. This is kind of a phased-in removal. For right now, the Type C lights have been removed from concrete barrier wall. So no longer
I don't know how much they missed. Some people just hopped up. There was a lag in it. Okay.
I'm sorry for that, guys. This is Jackie Morris here in the Office of Design. We had someone online that somehow was able to mute and unmute us, so we will continue with the presentation at this time.
Okay, the last revision is Index 11871, which is our single-post median barrier mounted sign. The IDSs have been modified for this index. It has to do with the revisions that go into the how it is to be used with temporary construction signs. If you notice here, it says Index 600. These plans, when you're used in the construction, they are to be generally, signs are to be post-mounted. When they cannot be post-mounted, and you can mount them to barrier walls, but they are required to be shown in the plans and they have their own separate pay item for work zone signs. So you can modify the signs if necessary to reduce the amount of signs that go on barrier wall. But this is the pay item. They have a new pay item for these barrier wall signs. Normally, most of these work zone signs fall under lump sum, but this one, due to the cost, does have its own pay item. So, okay. And Kevin's going to go through Index 400.
Okay. Good afternoon. I'm Kevin McDaniel. I'm going to discuss some of the changes that were made to the guardrail index. As many of you know, there were some major changes to this, and I wanted to kind of focus on this a little bit more. As we go through it, you may have some questions you'd like to ask me. You'll get my contact information at the end of this, so feel free to call me anytime to discuss any project-specific needs you may have, and we'll be glad to help you. Changes to the Index 400 were resulting from policy to increase the mounting height of new installations of guardrail from 1'9" to 2'1", which was effective on July 1st of this year. Again, I underline new installations. That's what the majority of the, that is what the criteria is for, not for old installations. So we don't want to go pulling up perfectly good installations of 27-inch guardrail and replacing it if we don't need to. There are some design standard revisions to the 2014 Design Standards e-booklet, which are now in the 2015 book. There were roadway design bulletins, 1405, which was released in March of 2014, and a follow-up bulletin, 14-13, which was released in June. Along with the 14-05 bulletin, there were other changes to the 400 series and other affected indexes listed below, 402 through 477. With all the issues there are some clarifications, there's some improvements that could be made. There's opportunities for improvements with the Index 400. So currently there's an ongoing effort for a major revision and reorganization of Index 400. The goal of it is to improve the organization of the criteria and the details within 400 to make it easier to follow, easier to understand, and to hopefully reduce any issues we may have in the field as a result of unclear or something that could be clarified. We plan to release this by design bulletin when completed. We don't have a schedule yet. This is going to be an extensive effort, and sometimes I like to use the term blast radius. There may be a large blast radius once we get involved in this and get into the weeds, but it will be a top priority of our office to get this index revised and reorganized. This is used on most all of our projects, and it greatly impacts the districts and their productivity. So this is of high importance to us. After we do revise this index, we're going to have an in-depth training which will be provided for the reorganized index and the PPM sections that are associated with guardrail. So there will be plenty of training on the reorganized index that is upcoming. So in the meantime, if you have any issues with Index 400, please call me, and I will be glad to help you resolve your issue on a project-by-project basis. Let's talk a little bit about why we decided to go to the 31-inch. Back in May of 2010, the FHWA released a memo that required all newly installed W-beam guardrail to be installed at a minimum height of 27¾ inches. This is to the top of the panel. We talk mounting height, and which is 2'1" to the center of the guardrail panel, but the 31-inch would be to the top of the panel. So when I say 27¾ I'm talking about to the top of the panel, and that's including construction tolerances. So FHWA's requirement was that states install new guardrails at 27 3/4 inches, including tolerances. Our old standard was at 27 1/8 inch, which was below that minimum requirement, and that was a nominal installation. So we had to move. We had to do something. We had to raise it somehow. So then it was for us to determine which height would we go to. There's a lot of benefits for 31 inch. There's increased construction tolerances. There's also accommodations for overpaving on projects that you have paving operations come in later on. There's also updated testing for installations at or behind curbs. There's crash test alternatives for mounting at slope breaks, crash tested alternatives. There's an increased margin of performance. Right now we have very good performance of our 27-inch guardrail that's been installed throughout the state. We have data to back that up. However, it's operating at the upper boundaries of its margin. So this 31-inch will kind of bring us towards the middle of that margin there. And also, most other states are adopting the 31-inch guardrail system. You know, that has a benefit where there's pool-funded studies that are done by multiple states, and allows us more opportunities to get involved in those pool funds and benefit from the research. 14-05, Bulletin 14-05, had some changes resulting from that. Let's go through those real quick. The mounting height, as we discussed, for new installations increased from 1'9" to 2'1". As a result of this, there's an asymmetric W-beam to Thri-beam transition section, which if you're looking at a in transition for our Thri-beam section, the Thri-beam height is actually 31 inches tall to the top of the railing, and so the 31-inch would not have the top of the 31-inch W-beam, and the top of the Thri-beam would be at the same elevation. Therefore, we require an asymmetrical transition piece. The W-beam panel joint shifted from the post to the center of the span between the posts. Therefore, the standard W-beam panel was revised to accommodate all post orientations and spacing in a 3 foot 1.5 inch increments. So you can see the holes allow for alternate and various post locations, and the joints are located in between the posts with our standard post spacing of 6'3". We also added a 15 foot 7.5 inch W-beam panel to allow splice location to shift from the post to the midspan. And in this example here, this is from the index. You can see if you have an end terminal or something here at the beginning of the guardrail section, a lot of the end terminals are crash tested with the splices at the post. So we allow that in order to offset the splice location in between the posts. We have to have an odd size panel, which is 15 foot 7.5 is what it comes out to be. We added a detail for a 15 foot 7.5 W-beam end anchorage panel with anchorage plate attachments to accommodate some of our end anchorages and the plate that has to be attached to it. Here's an example of that. We also have a summary of major changes with the roadside. Okay, let's see. The approach transition details, detail J, was modified. The length was increased from 43'9" to 56'3". This was required to accommodate additional W-beam panel, which is nested. And here's an example of the old and the new detail J. And this is just a small clip of detail J. This isn't the entire thing, but it shows what I wanted to show here. One thing we could look at here is we previously had a symmetrical transition piece. This was the 27-inch rail that transitioned to the Thri-beam. Here is the asymmetrical. The height of the top is the same. Also wanted to point out that the old detail J did not show a standard post, but you can see it in the plan view below it. I have circled where the joint was actually at the post, whereas you can see after we get out of detail J, we transition to where the joint is in between the posts. And also, we added the 12'6" W-beam panel, which we have a nested panel here. So as you're approaching the bridge railing or a stiffened railing, you'll hit a nested beam, then the thrive beam transition panel, and then the thrive beam, and then a nested thrive beam, and so on and so forth. So it's kind of a transition in stiffness as you approach a rigid barrier. The approach end anchorage assembly lengths increased, which requires a 15-foot 7.5 W-beam panel to shift the splice location. APL drawings will show each system of the end anchorage assembly within 53-foot 1.5 for the TL3 systems, and within the 40-foot 7.5 inch for TL2 systems. We've just given them this length to work in. There's some systems may be shorter than those lengths, but they have to show in their QPL drawings how their system transitions to the standard system within that length. All right, so this is a picture of some of the end anchorages there. We also added details for a height transition from 1'9" to 2'1" mounting height. This is in the design standard. It's to be used in special cases as determined by the district, where you're connecting long runs of new guardrail to long runs of existing guardrail, and you have to have some way of connecting it. One thing you want to make sure of is that the opposite end of the guardrail, of the new guardrail, is not bound by a fixed barrier, because you must use whole panel lengths. So you want to have a little flexibility of where the end of your guardrail is going to end up, because the post spacing in the holes in the panels have to line up. So you might get into construction issues if your other end of this is constrained. We have also the rub rail terminates at the first post in advance of the end anchorage assemblies. You can see here with the old system, the end treatment terminates at the post. Okay. Now that we have that joint out in the midspan here, and we give them a certain length to accommodate their end anchorage assembly, we want to make sure that the rub rail is outside of that. Okay. So after the release of the Roadway Design Bulletin 14-05, there were many unanswered questions and unresolved issues that necessitated the release of Roadway Design Bulletin 14-13. I'm just going to run through a quick summary of what we discussed in 14-13. The revisions to Index 400, we revised the minimum offset for the standard W-beam guardrail from 4 foot to 5 foot, and that's with a 6-foot 3-inch post spacing. We updated the offsets table on sheet 19, which gave you other alternates for reducing your dynamic deflection by reducing the post spacing. We added a redirected median end anchorage assemblies as an alternate to crash cushions. There's a product that's currently on the QPL, which will soon be the APL, under the crash cushions, and that will be moved to this new category. Okay. There's other minor clarifications that were introduced to the Index 14, and then we also added an instruction for Design Standards IDS 400. Currently, this only gives guidance on guardrail system length calculations, but it will be expanded during the reorganization of Index 400 coming up. There are also changes and revisions and clarifications to the plans preparation manual. We clarified some issues with shielding drop-offs, guardrail placement at or behind curbs. Just to mention to you guys, I mentioned earlier that there are national studies for the 31-inch guardrail where it's placed behind curbs. That's going to benefit us greatly. The chart and the current language in the PPM that was released by this bulletin was utilizing NCHRP 350 data, and we will, with the new reorganization of 400, we will use the data that was based on MASH criteria and is updated for a 31-inch guardrail. So that table will also be changing again. There's existing bridge end treatments. We also addressed extending guardrail and resetting guardrail, and we addressed guidance for RRR projects. We also revised the table of minimum offsets of the barriers. I kind of discussed this. We have the similar information in the design standards. This was revised based on the 2011 AASHTO Roadside Design Guide. This table correlates with the offsets table in Index 400, sheet 19. So here's a quick comparison of the two tables. The old's on the left, the new's on the right. And I just kind of wanted to show them side by side so we can see the differences. The W-beam with post spacing at 6'3", we used to have an offset of 4'0", excuse me. Now we have it with the same spacing of the W-beam. We have 5-foot offset. This is how close a fixed hazard can be behind the guardrail. The reason there is an increase is the table previously in the PPM was based on outdated criteria prior to NCHRP 350. And also the data, when you go to a higher guardrail, a taller guardrail, you have more rotation of the guardrail upon impact, and it deflects a little more. So you had that building on each other. You had the old table was based on pre-350 criteria, and on top of that, we've gotten taller. So this updated table to the right shows the deflections, and we also added a couple lines here with the stars. You can see we added a spacing of 1'6"3/4, and the reason for that is because previously we had accommodations for when you had a 3-foot 1.5 post spacing and an offset of 3. We wanted to have something, an alternative kind of similar in the table. So you'd have to reduce it to the 1'6" 3/4 spacing to get a similar offset distance behind the guardrail system. Same goes for the Thri-beam section. Okay, once we had a 2'8" deflection criteria, now we have a 2'10". If you have any questions, here's my contact information. Feel free to call me anytime and discuss it. And do we have any questions, Jackie? Let's see. Should 2'1" be 2'7"? I'm not sure what that's. Yeah. Okay. Yeah, there's a question about the 2'1". The mounting height on the guardrail, when we're talking about mounting height, we're talking about to the bolt holes. And when the contractor's driving those piles or driving the post, that's what they're measuring. They don't have the panel out there to measure to the top of the panel. So that's the reason we specify the mounting height in the design standards. So you may hear somebody refer to a 31-inch guardrail in a 2'1" mounting height. They're the same guardrail, but they're just described differently. Okay. Depth of embedment is the same for the post. The guardrail post embedments have not changed. So there may be an alternative coming in a revision later on to allow for deeper embedments near slope breaks on the edge of the roadway, and I'll get into that later on. But if anybody has a condition where they have a guardrail at the point of a slope break, they can just call me and we can discuss options on that. Oh, the post gets raised. I'm sorry. I misunderstood this question. We have the same post lengths, sorry, but the post actually gets raised a little bit. There is a question we had on the depth of the embedment of the guardrail, of the post. And we have the same length post, but the post gets raised a little bit. Our posts were 6'6", and the MGS, which is the Midwest Guardrail System post, was 6 foot, so we had a little bit to play with there, and we still have a little bit of tolerance left over. Okay? Now I will turn this back over to Chester to discuss some more of the signing design standards.
Thanks, Gavin. We've added 2 new indexes to our traffic standard indexes. I'm going to go over the first one was 11861. This is a single column cantilever ground mounted sign. We've had a lot of demand. Currently 11860 has some restrictions on what you can do with cantilevers, and we have a lot of need for advanced intersection signs requiring a bigger panel. And in some cases we have restricted right-of-way, and it cannot be put on a 2-post system. So there was a lot of people calling for how can we get us a bigger cantilever sign for those particular type of signs. So District 7 actually had a District 7 index that kind of addressed this. District 2 had a modification to that. So we actually pulled the District 7 indexes into District 2 and came up with a new standard index that will address single column cantilever signs. Now, it is a 2-sheet index. This is the second sheet. I want to clarify some things. One of the things is this should only be used where you have a limited amount of right-of-way and cannot install a 2-post system. If you have room to put a 2-post system in accordance with 17302, use the 2-post system. But if you've got limited right-of-way and the only alternative is a cantilever, then this is what this index is intended to be used for. There's a table in here. You can see that this index is designed for a sign size of 4x5, 4x6, 4x7, and 4x8. So it's very restricted on the sign sizes that it is intended for. If you get outside of these sizes, then of course the post columns and so forth do not work. This index is designed for 1 wind speed. It's designed for 150 miles an hour. So the sign detail constructing it in Miami would be the same as constructing it, in 110 mile an hour. Be exactly the same sign in the Panhandle. The next one I'd like to talk about is Index 11862. It again is a single column type of sign. We've got a lot of demand on beacons out there, particularly the RRFB and some of the school flashing beacons that we wanted to standardize. So we created the new Index 11862. It's entitled Roadside Flashing Beacon Assemblies. It consists of 7 sheets. The first 2 sheets are really typical type of applications that you can use. I'll kind of go through each one. There's actually 3 types of applications that you can install these. The first one is a solar-powered beacon. On solar-powered beacons, we are using a regular slip-based assembly, and mainly we're using this because you have a whole lot more the ability to use different type signs and their different wind speeds. So we don't have that with the transformer base. Second type assembly is a conventional powered beacon where the beacons are actually being driven by conventional power. All of those need to go on a transformer base because of the wiring in the base and pulling that wiring from a pull box to the transformer base. Now the third type is a specialized beacon assembly. These beacon assemblies are not a lot of them have not been crash tested. So when we came up with this index, we had to model it after existing crash data so that we felt like that we had crash-worthy designs. Some of those roadside flashing beacon assemblies, especially with the batteries and solar-powered units, ended up weighing more than what we had crash history on. So this particular type of assembly is used for where you have controllers and battery components that weigh more than 170 pounds. We require that all of that weight be placed on a secondary post near the right-of-way line, and only the warning sign with the beacons is actually installed within the clear zone. Now, we went through here and have several typical types of roadside beacons. The first one is a solar-powered warning sign. It's made for MUTCD type warning signs. Shows here it was designed around a 48-inch by 48-inch sign, and you can see that we have different column sizes for the different wind speed zones and for different sign heights. Now, the 7-foot sign height, of course, deals with the recommended sign height above the edge of pavement when it's actually in a flat area. You get into a slope, if the sign's installed 14 feet off the edge of the roadway with a typical rural type shoulder and a 6-to-1 slope, you would have a sign height of 8.5. So we have put in this particular sheet the calculations already done for you as to what the column size will need to be under these conditions. Now, if you vary this warning sign, use some other sign other than a 48 by 48, and you end up with other column heights different than 7 and 8.5 feet, you will need to show the details in the plans. The second type of system we're showing is the roadside flashing beacon assembly. We've been using these a lot throughout the state for mid-block crosswalks. Designers were having to put details in the plans of how we wanted these things installed. This one shows a typical installation. From here on out, there's a lot of these signs that are on transformer basis that may use conventional power that don't require solar panels, but it shows in here that that solar panel is optional. Since the roadside flashing beacons in a lot of cases can be installed as back-to-back signs, we move the controller and the battery compartment to the top of the sign. We are showing that should be used on all type of applications. It moves the center of gravity of the sign much higher and improves the crashworthiness of the sign. So this is the roadside flashing, rectangular rapid flashing beacon. We're trying to standardize our school zone flashing beacons, so we've added in here how we would like school zone flashing beacons to be installed, showing a 2-beacon assembly, and of course the speed limit and the measurements to the different components. Now, this again can be either a solar powered or a conventional powered unit. This is another variation of the school regulatory sign. A lot of these signs, they want the speed feedback sign installed. This shows that same assembly with a speed feedback sign. The last one is a regulatory sign with speed feedback. A lot of our rural facilities or where we have modified speeds, they on curves or something like this where you have restrictions, they want regulatory speeds with a feedback. So the last one is a regulatory sign with speed feedback. So that completes our new indexes. There's a couple of things I would like to bring to your attention on some existing indexes that we have modified. This is in Index 17346. It deals with our special emphasis crosswalk markings. You know, what we're going to talk about is the general notes. We have changed the requirement. The old general notes used to say that we suggest using preformed thermo for these special emphasis crosswalk markings. We have changed that. It is a shall condition. You notice at the bottom, the longitudinal lines in special emphasis crosswalks shall be preformed thermo. We will still allow the 12-inch transverse line to be out of hot applied thermo, but since pedestrians have to walk on these 24-inch wide lines, we are requiring preformed thermo to provide sufficient skid resistance and to ensure we have skid resistance. The next one is Index 17347. Again, it was a clarification in the note. The note used to read, all bicycle pavement messages shall be preform thermo. The intent with that note was that both the symbol and the arrow be of preform thermo. We've noticed a lot of set of plans, the symbol was out of preform thermo, but designers were putting in there the arrow could be out of preform thermo. Both of those markings need to be preform thermo to provide adequate skid resistance, to ensure skid resistance for those type of markings. So all the bicycle pavement markings need to be specified as preform thermo. The last revision I'd like to go over is Index 17515. We've had a lot of demand recently on the use of a top mount fixture. Currently 17515 was strictly an arm type design. It was not intended for a top mount fixture. Most of the top mount fixtures designers will have to create a special design when really there's not a whole lot of difference in the thicknesses and the design of the pole. So we have now inserted a top mount pole. There is a table on sheet number 2 that gives the wall thicknesses for the different mounting heights for these top mount fixtures and so forth. So from now on, you should not be using the special design pay item for these type of poles. Just use the standard aluminum pay item. That completes the areas that I want to go. I know we had a little bit of a problem with Index 600, so let me go back to Index 600 and I'll go over Index 600 one more time. Okay, Index 600 on sheet number 4. We've always had a section in there on temporary raised rumble stripes. The way they were called for was when called for in the plans by the designer. We have changed our policy on that. We are now requiring temporary raised rumble stripes to be used on all two-way flagging operations. Based on the reason we did this was we've had 5 fatalities in the last 5 years where vehicles running into the back of other vehicles stopped in a flagging operation. So these are now being required for all work zones with speeds greater than 45 miles an hour and with durations greater than 1 hour. The second thing I'd like to bring to your attention in 600 on sheet 9 is we are eliminating the steady burn warning lights on our devices. The first removal is with the warning lights on concrete barrier wall, and the changes in 2015 reflect removal of the Type C steady burn lights on barrier wall. They will no longer be required. So with that, I think which concludes our roadway and traffic and guardrail section. If you've got any questions, we'll be glad to answer them. I know I have one question already that had to do with the RRFB. Question was on the RRFB was this is the RRFB, and it shows a dimension in there of 7 feet. 7 feet from the shows a dimension of 7 feet from the ground to the bottom of the pedestrian sign. Some people have questioned that why we did not hold the 7 feet to the bottom of the arrow. The MUTC does allow you to, on the primary, keep the primary panel at 7 feet. Secondary panels can be lower than that. The testing of the RRFB and its effectiveness was that it needs to be the flashing beacons and the sign needs to be lower in the cone of vision than 7 feet. So all of the research that was done tested this thing with 7-foot mounting height to the bottom of the sign. So we purposely set that distance as 7 feet, not to the bottom of the arrow panel. Another one we have is, would the cantilever sign need to be called out in the plans or part of the field adjustment? This is a single column sign. It should be called out in the plans as a cantilever sign. Otherwise, I mean, if you show a sign that's 4 by 5 and with a pay item on a single column sign, this would be, of course, lead you to this index. So the only index that is available for a 4 by 5, 4 by 6, 4 by 7, and 4 by 8 would be this index. So if you're calling out a 4 by 6 sign in the plans, it should be should realize that this is the index that they will be using, because 11860 would not apply. Do we have any other questions?
Chester, I have one. What do the raised rumble stripes materials consist of?
Okay, there are 2 types of rumble stripe material. One of them is the same material that we used for the materials in 518 for the raised rumble stripes. Are made of a thermoplastic type material. They can be used a few times. They have an adhesive backing, so when you put them down, you pull off the sticky tape and apply them. When you pull them back up, you have to put a backing on it to try to keep the thing sticky. You can use them a couple of times. That is one type. It's kind of the cheaper version. The other one are the molded polymer type, which last for years, numerous hits. I think most people that do MOT or probably will get the molded polymer ones, but there are 2 different types on the QPL, and you can look at the QPL and see what is on there. Any other questions? Okay.
Is this the only microphone? We ready to go? Good afternoon. This is Steve Nolan with the State Structures Design Office, and I'll be going over the updates to the structures-related design standards and associated instructions. First, we'll go through a brief guide to the FDOT publications. I'm going to skip over the website navigation since Alan's already covered that this morning, but it'll be in the presentation if somebody only wants to download the structures portion off the website. Then we'll go over some of the general revisions, a few of the deleted standards, a couple of the new design standards that have been published this time around, and some significant revisions. We'll also briefly cover some minor changes to the drainage standards that were structural related. And then we'll look into the crystal ball to what's coming up in the next year or so. So as you should be aware, the instructions to design standards are intended for the designers, and the design standards themselves are really intended for the contractor, form part of the contract documents. The instructions
were originally developed by the State Structures Design Office, and now we have the Roadway Design Office coming on board and presenting or developing more of these. The design standards, as you know, we have both the regular design standards, then developmental design standards, which there are a few out there, and there's one I'll talk about today. And then the design standards revisions that come in between the yearly publishing cycle, if necessary. So Alan went over these website navigation details earlier, so I'll just page through them relatively quickly. On the State Structures website, we also have some supplemental documents that dovetail with the design standards. They can be accessed off the Structures main page under this More tab. Then you'll come up to another page and you click on the Structures Design Standards Details and Data Tables link. In there you'll find links to the MicroStation cell libraries that contain all the data tables that are associated with the design standards, and these are updated automatically on publishing of the release of each new series of design standards, so you don't have to wait for the CAD load to come out, which usually is delayed a little bit behind when the design standards are released. There are also some other cell libraries out there for load rating that aren't actually associated with a design index, so those are available also when we update those in January and July of each year as necessary. So they can be immediately downloaded from there also prior to the CAD load coming out. And we also have some links to the previous trainings that are out there too for those that don't know how to navigate to the roadway training website. Moving on to some of the general revisions, the QPL name is changing very soon. So for the 2015 series, we've updated all those cross-references. The structures manual has been slightly renumbered. We've deleted some of the empty volumes that were there. So we've moved the volume 9 to volume 3. And there'll also be a new volume coming out shortly related to fiber reinforced polymer products. We updated quite a few of the traffic railing related design standards due to the change in the guardrail height to 31 inches, which was just previously talked about. And then we modified some of the IDSs for the traffic railings to clarify the intention of adding conduit into those elements. The two design standards that were deleted from that were under the structure's responsibility, the geotextile criteria, that is now going to be in a new specification that will be published shortly under section 985. So all that information is going to still be available. And then the fender system polymeric pile index 21900 was removed also. That one will be replaced shortly. There will be a design bulletin coming out. Well, the index won't be replaced, but the polymeric fender systems will be replaced, and I'll talk about those later in the presentation. Some of the cells were updated. Obviously, any reference to QPL was changed to the new APL. General cleanup and some of the notes were changed. Some of the minor changes were correcting missing columns on the 11320, which is span sign or cantilever, I can't quite remember. Added another note on index 177743. We updated the design example for the Florida I-beam bracing, or the pre-stress beam bracing standard, 20,005, and some of the terminology was changed in the tables that are on that index also. And then for the bearing pads that relate to the AASHTO Type 2 beams, those have been reconfigured, and I'll elaborate on that a little bit further in the presentation, but the associated data table was changed to reflect that new naming convention. And then under the, not related to design standards, but data tables for the load rating on pre-stressed concrete bridges, we've removed the row that required the Service 3 check for the FL120 permit vehicle to be included in the load rating table. There were a couple of new cells added. These were actually part of the 2014 revisions that came out mid-year, relating to perimeter walls, and one for access doors for steel box girders. I've lost my title. Okay, this is Index 5250. This is the perimeter wall that was released as a design standard earlier this year under the revision process. Previously it was a developmental design standard, but in the updated version we've added the masonry block option to supplement the precast panel option. So that's the masonry block option shown on the left there, with slightly different post, obviously. These are all constructed in place. We have not, I don't have any photos or projects that have utilized the new standard yet, but I'm sure they'll be coming in the next year or two. The reason for developing the perimeter wall was initially to give the districts a visual barrier that could be used when sound walls weren't justified under the DOT policy. The structural design bulletin came out earlier this year with more information, so you can refer to that if need be. And as part of this process, we archived the developmental design standard that was previously used. That design standard had a lot more options for the foundations, and the new index simplified or reduced those number of options so that they correspond more closely with those that are available for the masonry block wall. Also, as part of this, the specification 534 was updated to include the perimeter walls and add masonry block information in there. The previous developmental specification obviously has been removed from the website now. There are also a number of other manuals that were updated to implement the policy for the use of the perimeter walls. So you can refer to those documents listed there below if necessary. The access door assembly for steel box girders was, as I mentioned before, released earlier this year, in January I believe, but it is now officially in the Design Standards e-book. And Index 480, we just refined or clarified the terminology for the skew angle. That one's pretty straightforward. Shouldn't affect designers. On the pedestrian railing indexes, we actually had to correct a erroneous dimension there for the height of the lower portion of the pedestrian railing that contained the picket panel. Under the noise wall indexes, the standard fire access hole details have been removed. The fire access panels were routinely placed without the need being there for them. And so now there's some additional guidance in the IDF when those can be used in future. And then project-specific details will be required. You can always refer to an older index if that ever becomes necessary. Okay, we seem to be updating the the Index 5200 every year. So this year is no exception. We've actually expanded the tables at the end of the index to include a full 22-foot height wall for the 150 mile an hour wind zone. To achieve this without changing the dimensions of the post, we had to reduce the post width. So the last several steps in wall height are actually based on a 15-foot post spacing rather than 20-foot post spacing. You'll see that in the next slide. We also changed the designation of the wall height to be the nominal height above ground rather than the actual panel height. So the design now incorporates an additional foot in the design capacity to accommodate the intention of providing a full 16-foot, 20-foot wall height, as opposed to before where 6 inches of the panel was buried. So for a nominal 12-foot wall, you would only have 11-foot 6 exposed. Here's a couple of shots, screen captures of those new tables. The 15-foot post spacing is in purple down here on the bottom right. So there were some slight changes to the reinforcing requirements because of the small increase in the post height. On the left-hand side here, you can see typically for a 22-foot high wall, then the post height above the top of the auger cast foundation is now 23 foot and a half inch, whereas before it was only 22 foot and 2.5 inches. Oh, actually 22 foot and a half inch. Under the traffic railing indexes for atop of MSE walls, the junction slab has had some minor changes made to it. This is an attempt to try and provide some consistency in the thickness of asphalt that we typically provide at the edge of the junction slab. So previously, this transition here from the rigid junction slab into the pavement zone varied significantly depending on the cross slope. Typically, for a 2% cross slope, it was around 7 inches, and then if you got into super elevation, it reduced down to a minimum in some cases of the friction core thickness, or 1 inch and 3/4 at least. And then on the high side of super elevation, it could get up well over 1 foot thick, simply because of the constant cross slope that we had for the junction slope. We've attempted to rationalize that a little bit now, so it's being chopped off here, but this dimension here would show 6 inches on the design standard, and then the contractor has the option to vary the slope of that junction slab if necessary to follow the cross slope of the pavement as it varies and reduce the amount of asphalt overbuild that they need to place on top of the junction slab. Keeping with the junction slabs, we've also allowed slip forming of these elements as well. I have a short video on the next slide to show where this was done recently down in District 7. Typically, to do that, though, we will need the contractor to submit shop drawings to show how they're going to accommodate the 3 inches of cover that's going to be necessary. Typically, the slip forming has a lot more required tolerance than stationary forms, so there is a need to increase the side cover out here to 3 inches when we're utilizing slip forming. So those details will have to be submitted for approval on a project basis. Here's a short video of showing the slip forming of that junction slab. The overhang portion of the coping is obviously supported on formwork, and based on contractor requests and this successful project, we're now allowing this on current projects, and those would have to be requested through the project administrator, because the design standard probably was relevant at the time of that contract letting doesn't allow the slip forming, but the new 2015 design standards will. So any projects let from January on won't need to submit any special documentation to utilize this option. Okay, for 6011, the gravity wall design standard, we've added some additional criteria in there to show the minimum toe slope that would be permitted for certain conditions. Previously, all we showed was the foundation being level at the toe of the retaining wall. So now there's some additional guidance there. We also had intended to add the segmental block walls as an option for this low height retaining wall, but it's been decided to release that as a developmental design standard. That should be coming out very shortly. There is already a specification out there for the segmental block walls, and that will be utilized with the new developmental design standard 60,011. So I look forward to that, hopefully by the end of the month. Here's just a few screenshots of the details that will show two options for the gravity wall, either utilizing soil reinforcement for a traditional segmental block soil reinforced wall, or a permeable concrete backfill to actually be more like a traditional gravity wall. Sticking with the 6000 series, there's a few other minor revisions. Let's see, 60,020, just minor note updates and corrections. 60,200 is the light pole pedestal for the MSE walls or retaining walls. That is now allowed to be either precast or the currently allowed cast-in-place version. And there's a couple of vendors out there that have details developed to accommodate that. So that's an option now for contractors. So don't be surprised if you see that shop drawing being submitted on any of your design projects. Also on the GRS bridge abutment system, the EOR needs to detail the rip-rap rubble in the plan, so that guidance has been added to the instruction for design standard for that index. Well, that's a developmental index. These are some minor changes to the clips at the ends of the pre-stressed beams to accommodate skews, minimize the amount of bottom flange falling that we could possibly get. As I mentioned in the beginning, the bearing pads for the AASHTO Type 2 beams have been redesigned. This is to accommodate will actually provide wider bearing pads that are narrower and accommodate more efficient design. Also makes them more consistent with the way they would integrate with the bearing plates if they were required on a particular beam. So these new bearing pads are being designated AA or AB. You can think of the first A as standing for AASHTO, and then we've got an A or a B pad. Previously there was A and C because the B pad got left behind when we reintroduced the AASHTO Type 2 beams because it was not an efficient pad. The bearing plates, the indexes that reference these have also been updated. They also have the minor changes to deal with the corner clips that were shown on the pre-stressed beam standards. The other bearing plate index, 20,512, has similar changes to it. There was also a clarification on the spacing for the studs for the Type 2 plate. These things happen when you're trying to double dimension an index to deal with two different types of beam shapes and bearing plates that are associated with them. We also, we believe, simplified some of the dimension adjustments that you have to make for special cases for the Type K pads. So hopefully those will be a little bit clearer now. For the approach slab standards, the optional base group 2 has been opened up to just optional base and a reference added to see the railway plans. I don't think there's anything else on that index worth talking about right now. For the fender systems, the department is no longer going to be supplying the clearance gauges. Those will be supplied by the contractor. And as such, the designer will need to show in the plans the clearance gauge numbering system based on the requirements laid out in the instructions for design standards. There's Coast Guard has a code of federal regulations that deals with the size and spacing of that lettering for the clearance gauge. So we refer back to that. Also, I mentioned that Index 2190 was deleted. This was the polymeric pile standard index with standardized designs. Due to the variability of the number of different vendors' products out there and the potential configurations for efficient design, it's decided a while back to change that process to a contractor submitted design process, which is currently in its final stages of being developed. So I expect a temporary design bulletin to come out shortly on dealing with that. We're ready for the new year. As I mentioned before, there was these are the access hatches. What did we do? Okay. So as part of the access hatch assembly details for both the steel boxes and the concrete boxes, we modified this locking mechanism inside the, well, actually you can't see the locking mechanism because it used to be on the bottom side of the box. Now we have this cotter pin assembly which allows maintenance personnel to unlock the access hatch from inside the box girder if necessary, or access it from the outside as we currently are able to do. There were some minor changes to the drainage standards that were structure related. I don't believe Alan talked about those. You can refer to those drawings if necessary. We also clarified the concrete box culvert extension guidance for when you're extending an existing box culvert. So you can refer to those if you're involved in box culvert extensions on your project. So looking ahead into my crystal ball, or someone's, there's going to be a lot of effort coming forward on fiber reinforced polymer products. We've just released the FRP bar bending details that's out on the Developmental Design Standards website. This is really a component of what designers will need to design for FRP on a project. So it's just one of the tools that's available, and more will be coming. The developmental specifications have just recently been published also. I'll go over some of those in the next slide. Then we'll talk about some of the future developmental standards that are coming forward. We'll also have the segmental block wall gravity wall developmental standard coming out within the month, and we're considering precast F-shaped traffic railings, and we also have some precast bent cap details that are under development. We have some projects that are actually under construction right now, so hopefully we'll learn some good lessons from those and implement the developmental standards as soon as practical. So the FRP bar bending details were actually published this week, so go out and take a look at those on the website. There is a limitation on the types of shapes that you can have, because these have to be specially extruded. You can't bend them like you can with traditional reinforcing. So obviously there are some limitations there. The instructions for design standards give some guidance or a design aid on how you can combine these shapes to satisfy the structural needs that you may have on a project. Here's a listing of the developmental specifications that have just recently been published. To utilize these, you need to contact the monitor who's listed on the specifications website. Then those specifications would actually go with any of the design standards that are coming out. The square pre-stressed concrete piles with the carbon fiber strands and carbon fiber stirrups will probably be the next one that we release. There was a good presentation today, a structures research update that they'll probably be posted in the next few weeks on the Structures Research Center website. So if you want some background on carbon fiber pre-stressed concrete piles, and that's a good resource. We'll also be looking at developing concrete sheet piles with carbon fiber strands and glass fiber reinforced stirrups or spirals, just to keep the cost down a little bit. The glass fiber reinforced polymer bars are a lot cheaper than the carbon, obviously. We have a project in the works that's going to utilize these standards, and there'll be more guidance coming out in Temporary Design Bulletin shortly. Okay, just finishing up now. There's some just general information on the design standards. Our group is here to help you when you need it, but we do encourage you, before you call on a question about a design standard, to fully read the IDS associated with that. There's a lot of good information in that. So with that, that's all that I have for presenting today. If there are any questions, we can attempt to answer those right now. We'll give you a few seconds to type those in. If not, if you send them in, I guess, later, then we'll be able to post those on the website with comprehensive responses. Do we have anything else going this afternoon, Jackie?
Nope.
Looks like I was the last one, so since there don't appear to be any questions right now, we'll finish up for the day, and we appreciate you attending, and give us a call if you got any questions.
Yes, and the presentation will be posted on our Engineering Academy website probably tomorrow or the following day. Thank you.
Bye for now.